All right, on to astronomy. First thing, a couple little reference places. All right, highest point in the sky above your head is what we call the zenith. The boundary between the earth and the sky, the horizon. We use those as reference places, reference points. All right, if you can imagine if you were standing out in the middle of a field, open field, we call it the dome of the sky because it almost looks like the stars are little white dots on a dark background out there. And that's what they used to think it was, and it made sense because that's the way it looks. All right, so finding locations on what we call the dome of the sky or the celestial sphere. It works kind of similarly to latitude and longitude. We have to have 2 points, just like we have latitude and longitude, 2 points to give us a grid point. We have to have 2 points on the sphere. Only those 2 points are to have different names. The first one's called the altitude. Right? It's how far above the horizon are we. If we imagine the horizon as 0 degrees, and the point directly above your head, the zenith, as 90 degrees, we can picture any number of degrees in between that we can approximate. Notice we use the letter H to represent altitude, and that comes from height. Yeah, they call it altitude, but they use the H kind of coming from the word height. All right, so the horizon has a height or an altitude of 0, and the zenith has an altitude of 90. And if you look at that particular star that that person in the middle of that dome is looking at, that's about 50 degrees above the horizon. If you figure halfway is about 45, so about 50, it's a little more than halfway, so about 50 degrees. So we say that star has an altitude of 50 degrees. Notice there's no N, it's not north. It's just degrees above the horizon. Think of an angle. All right, that's all it is. Second point we have to find is an azimuth, which is just a compass direction. Okay, compass direction. We start at north, and we label that as 0 degrees azimuth, and then we move clockwise around the compass. So east would be 90 degrees, south would be 180, west would be 270, and then back to 0 again. So if we look at where the 0 would be, that's our starting point. Okay? If I take that compass, that top-down view here, this top-down view compass rose, and I lay it on the table so that I have a flat surface with a 3-dimensional dome over it. If this is 0, going clockwise like this would be the same thing as going clockwise like this, around this way. Okay? So if we label the north as 0, we can then go 90 degrees and label east, 180 south, 270 west. That gives us our 4 cardinal directions. And then we can see that the angle in this picture is not quite all the way to 90 degrees. It moves clockwise, but it's not all the way to east. Okay, so what is that? Well, it's going to fall somewhere around there. It's right around 75 degrees. Now, do we know if it's exactly 75? No, it's an approximation because it's a picture. So, but we know it's got to be less than 90, so 75, 70, 80, somewhere in that vicinity. You know that's what it's got to be. And that gives us our azimuth. And again, there's no direction. It's just a number of degrees. It's the number of degrees out of a full 360-degree circle. And then we just put them together. All right? So in this particular picture, I have a 3-dimensional dome drawn. You can see I have north all the way to the right, and then coming towards you clockwise, 90 would eventually be east, south is 180, and then the 270 west is on the other side of the dome where we can't see. So there's our azimuth. And then if you start the 0 where the north is, and you can see the 90 at the zenith, as we move from 0 to 90, that gives us our altitude. So if I plot a point right there, that is on the horizontal line of 20 degrees. Here's the 0 line. This one's 10, this one's 20 right there. And then If this is 0, this line right here is 0 azimuth. There's 10, 20, 30, and I'm on the 40-degree line for azimuth. So I write it like this. Altitude is 20 degrees because it's 2 lines horizontally above the horizon. And the azimuth is 40 degrees. It happens to be 4 lines clockwise from north. Each line is 10 degrees in this diagram. All right, another one. Looks like we're between this horizontal line and this horizontal line. So we're between 30 and 40, so probably like 35 degrees north. And then we're falling right on the 100-degree azimuth line. So we're going to say height of 35 degrees, azimuth 100 degrees. 2 points. In the sky, we can find a star, find a point. All right? If I put a dot directly on the top where the zenith is, we know that's an altitude of 90, but there is no azimuth. If it's sitting right on that one point on the very top, you can't line it up with any particular line, or you can say you can line it up with all the vertical lines. It lines up with this one, it lines up with this one, it lines up with this one, it lines up with this one. So it lines up with all the vertical lines, so it doesn't have an azimuth. So it's just a height of 90 degrees, just an altitude of 90 degrees. That would be right at the zenith. And you can do that anywhere else, right? If I threw another one on here, if I put one right there, you're going to say 40 degrees is your altitude, and 140 degrees is your altitude, because it's on this line right here. Okay? And it's on this vertical line, so it's 140 degrees of azimuth. Okay? You can do that for any of them. All right. Energy. Electromagnetic energy. This is the spectrum, electromagnetic spectrum. Again, just a real quick, you can see this here on the bottom of page 14. Notice I drew short wavelengths on this end because it says decreasing wavelength here, and I drew long wavelengths over here because it's increasing wavelength there. And I also gave this another name. Infrared is also known as heat. This little teeny bar in the middle is the portion that humans can see, so we call it the visible portion. And they spread it out so we can see the colors of the rainbow: red, orange, yellow, green, blue, and violet. All right, so that's on page 14. That's a picture right out of it. Okay? And notice there is some crossover. Okay, there is a little crossover. Some gamma rays are the same wavelength as some X-rays. Some X-rays are the same wavelength as some ultraviolet. All right? But you can see down at this end, the shortest wavelength means the distance between the crests is really short here at the gamma end, but at the radio end, it's longer. All right? So how do we talk about the wave? Well, we talk about the wavelength in terms of basically crest to crest. The further apart the crests are, the longer the wavelength, and the further this end it is. We differentiate the different energies out there by how long their wavelengths are. Things on the long end tend to be less damaging to us. Okay? They have a longer wavelength, but they have a lower frequency, and it's the frequency that causes damage. Where the ones over here at this end have a short wavelength, but they have a high frequency, and so they're very damaging to people. Right? Ultraviolet gives you a burn. X-ray, yeah, you can see your bones, but if you did it long enough, you know, you're gonna, if you X-rayed your hand over and over and over again for years, you're probably gonna get cancer there. Gamma rays, super high energy, okay, cancer causing again. All right.